In this lecture, we will explore the Google Compute Engine. A virtual machine is like a physical hardware server, but running in the cloud using something called a hypervisor. This is run on large shared servers and lets Google isolate resources and sell them on a per-server basis with different resource combinations. Virtual machines provide the most flexibility as you can spin up thousands of servers with various sizes and scale them from the GUI, command line, or batch scripts. A single VM instance can now have up to 160 CPUs and 3.75 gigabytes of RAM. This is as of June 2019. When it comes to storage, you can have local SSDs. These are local solid-state drives, block storage, and they can be up to 3 terabytes. Network storage or hard drives can be up to 64 terabytes in size, and they're attached to VMs as persistent disks. These persistent disks can be detached and reattached to another virtual machine while retaining data. You can also take snapshots and create a new disk from its data. All the data is instantly encrypted by the necessary standards. The infrastructure these VMs sit on is the same as the one Google uses for their own products, which serve billions of users. They use live migration technology, which allows for updates and servicing to occur on the infrastructure while keeping your VM live. Here, your VM is temporarily shifted to a different physical server and moved back when the servicing is complete. All this happens seamlessly behind the scenes. So the Google Compute Engine offers predefined machines with common configurations, or you can create your own with your own specifications and needs based on the workload requirements. Different versions of Linux and Windows Server are supported. You can have Debian, CentOS, SUSE, Ubuntu, Red Hat, FreeBSD, or Windows Server. You also have container support with Docker containers on Compute or Google Kubernetes Engine. The pricing is similar to Amazon Web Services product EC2, who came up with this idea to sell scalable VMs as a service. You're billed for the utilization per second and get discounts for committed use. Amazon actually came up with this idea because they were experiencing large spikes during the holiday season, during Thanksgiving and Christmas, and they realized that for the rest of the year, their servers were just sitting there idle. So they decided to reuse them and sell that compute power as a service. Each virtual machine instance belongs to a project. You specify the zone, operating system, and the machine type when creating an instance. By default, each Compute Engine instance has a small boot persistent disk that contains the operating system. When applications running on your instance require more storage space, you can add additional storage options to your instance. An instance can transition through many states. Provisioning. An instance can transition through many states as part of its lifecycle. This provisioning, resources are being allocated to the instance. The instance is not running yet. Staging. Here, the resources have been acquired and the instance is being prepared for first boot. Running. Here, the instance is running. You can connect to the instance shortly after it enters this state. Stopping. The instance is being stopped. This can be because a user has made a request to stop the instance or there was a failure. This is a temporary status and the instance will move to terminated once the instance has actually stopped. Repairing. The instance is being repaired. This can happen because the instance encounters an internal error. During this time, the instance is unusable. If repair is successful, the instance returns to one of the above states. Terminated. a user stopped the instance or the instance encountered a failure. You can start the instance again or delete it. You can see the diagram here, which shows how the states transition. So you go from provisioning to staging to running, and from there, if you issue a stop command, the instance will go into a stopping status. Once it's at the terminated state, you can issue a delete command which deletes the instance, or you can issue a start command to bring it back into provisioning and staging and running. However, from the running state, you can also issue a delete command for it to directly get to delete. A machine type is a set of virtualized hardware resources available to a virtual machine instance, including the system memory size, virtual CPU count, and persistent disk limits. In Compute Engine, machine types are grouped into different families, curated for different workloads. Currently, you can choose from general-purpose machine types, memory-optimized machine types, and compute-optimized machine types. You can create custom machine types if your workload has special needs. This will cost higher than the pre-configured machines. Here's a table that shows the differences between the different machine types. If you're not sure which one is the best for you, then you should probably go for the general purpose machine type, as it offers the best price-performance ratio for various workloads. Typically, most resources are priced based on usage. In addition to that, if your workload is stable and predictable, you can purchase a specific amount of virtual CPUs, memory, GPUs, and local SSDs for a discount off of the normal price in return for committing to use it. That commitment needs to be between 1 to 3 years, and the discount can be up to 57% for most resources like machine types or GPUs. The discount can go up to 70% for memory-optimized machine types. Another way you can get a discount is through sustained use discounts. These are automatic discounts for running specific Compute Engine resources for a significant portion of the billing month. The discount ranges from 20 to 30% depending on the resource type. So for example, a general purpose can get you up to 30% off, and a memory optimized machine types can get up to 20% off. An instance template is a resource that you can use to create virtual machine instances and manage instance groups. They are a convenient way to save a VM's instance's configuration so you can use it later to create new VM instances or groups. An instance group is a collection of VM instances that you can manage as a single entity. So you have managed instance groups and you have unmanaged instance groups. Managed instance groups operate applications like web frontends across a group of identical VMs created with a template. Unmanaged instance groups are those that you manually load balance a group of VMs yourself. Managed instance groups have quite a few benefits. There is high availability, so if an instance in that group fails, Managed Instance Groups automatically recreates it exactly to its original specifications. There is a health check system called auto healing, where if you set that policy, then the health of that instance is constantly monitored. Application load can be spread within the region across multiple zones, and you can use load balancing to distribute the traffic, where the service provides auto scaling up and down and increases and decreases the number of instances depending on the load. Automated updates. You can roll out updates with minimal disruption depending on the setup that you use. So if you're going to have a new security patch or a new update for a specific part of your application, if it's part of the managed instance groups, then you don't have to fully bring down the entire server. You can see the overview of the MIG capabilities here and the common workloads. When you group instances this way, you're going to get high availability and scalability, as well as a lot of safety features, as we've just seen. Regional and zonal groups. You can create two types of managed instance groups. The zonal managed instance group deploys instances to a single zone. A regional managed instance group deploys instances to multiple zones across the same region. Both types offer all of the advantages of managed instance groups. The regional ones add higher availability by spreading application load across multiple zones, which protects your workload against zonal failure, and regional offers more capacity with a maximum of 2000 instances per regional group. Load balancing and autoscaling is available for groups of instances. GCP load balancing uses forwarding rules in order to balance resources and performance. It matches certain types of traffic and it forwards it to a load balancer when it thinks that it needs to be distributed. So a forwarding rule can match TCP traffic, that's network traffic, destined to port 80, which is on the internet, on a local IP address 192.0.2.1, then forward it to a load balancer, which then directs it to healthy virtual machine instances. Traffic is also routed to the closest virtual machine. We'll take a closer look at load balancers in our networking lecture. On the other hand, you can also have unmanaged instance groups. Here, you can group instances that are heterogeneous, and you can manually add and remove instances as per your need. You can apply load balancing here, but you won't get any of the other benefits of the managed instance groups. It's not recommended for deploying highly available or scalable workloads. Sole tenant nodes. A sole tenant node is a physical compute engine server which is dedicated specifically for your virtual machines. So you're paying for a physical server. This is used for physically keeping a group of virtual machines separate from other projects. A typical use case for this would be a payment processor who needs to follow certain rules for compliance purposes. Here, each node is associated with a single physical server. These nodes can be grouped and multiple instances can be run on these nodes. There is a minimum VM size of 2 virtual CPUs, and this feature is only available in certain zones. So you can't really have a micro instance or any other instance that has less than 2 CPUs. A region is a specific geographical location where you can run resources. Each region contains multiple zones. Usually there are more than 3 zones. Some resources in GCP are zonal and others regional. What that means is some resources belong to a certain zone and other resources are tied to a region. For example, instances, disks are zonal and they need to be in the same zone to work together. Static IP addresses are regional and can be assigned to resources in the same region. Other resources like images, snapshots, firewalls, etc. are global and they're not tied to any zone or region. Compute Engine offers several different types of storage options for your instances. Each of the following storage options have a unique price and performance characteristics. The basic persistent disk is created with the OS when a VM instance is created. This is also the boot disk. You can have a persistent disk, which is an SSD, either zonal or regional, and you can have a persistent disk that's a regular hard disk drive that's zonal or regional. You can also have local SSD, cloud storage buckets, or create a file server to use as a network file system, or mount a RAM disk. Regional storage provides synchronous replication across two zones by default. Storage options. Zonal standard persistent disks. The storage type is for efficient and reliable block storage. Provides a maximum space per instance is 64 terabytes, and the access is zonal. Persistent disks are predictable and they scale linearly with provision capacity until the limits for the instance is exhausted. The data on each persistent disk is distributed across several physical disks. Compute Engine manages the physical disks and the data distribution to ensure redundancy and optimize performance for you. You cannot attach a persistent disk to an instance in another project, and there's a limit of 16. Now, regional persistent disks are an option when write performance is less critical than data redundancy across multiple zones. They, however, do provide durable storage and replication of data between two zones in the same region. Other than that, they're pretty similar to the zonal disks. SSDs are much faster than regular hard drives. They provide fast and reliable block storage up to 64 terabytes. Local SSDs are even more faster. However, their performance for local SSDs scales up until you reach a total local SSD storage space of 1.5 terabytes. That's half the capacity. After that, the performance is going to just stay the same. Unlike persistent disks, you must manage the striping on local SSDs yourself. The data that you store on a local SSD persists only until the instance is stopped or deleted. Cloud storage buckets. Cloud storage buckets are the most flexible, scalable, and durable storage option for VMs. If the application does not need a lower latency of persistent disks or local SSDs, you can go for this option. The performance depends on the storage class that you select and the location of the bucket relative to your instance. The scope is global and the data redundancy is regional or multi-regional depending on how it's set up. Each Compute Engine instance belongs to one VPC network, which is a virtual private cloud network. Each virtual machine instance can have one primary internal IP address, one or more secondary IP addresses, and one external IP address. On the same VPC, you can use the instance's internal IP address to communicate with each other. The external IP address is used only for communicating with the internet or with resources that are outside of that virtual private cloud. To communicate with the internet, you must use the instance's external IP address unless you have configured a proxy of some sort. Similarly, you must use the instance's external IP address to connect to instances outside of the same VPC network unless the networks are connected in some way, like a VPN. Both external and internal IP addresses can be either ephemeral or static. We'll see these details in the IP addresses section. The external IP address is used to communicate with not just the internet, but also other components that are outside the zone or outside the region, depending on the resource. For load balancing, you need to set up forwarding rules. We'll see this later in a later lecture in the networking section. VPC cloud networks on GCP also have an internal DNS service that allows them to communicate with each other with their DNS names instead of the IP addresses. Now let's go ahead and create a Compute Engine instance. In this demo, we'll learn how to create a Compute VM machine. So we're back here at our Google Cloud Platform dashboard. If this is your first time, make sure you have your billing set up and you're selecting the correct project. So click down here and you can create a new project or select an existing one. In my case, I'm going to choose Compute Demo. Make sure the correct project is selected. And now we go to our navigation menu, go to Compute and Compute Engine. Click on this. This opens the dashboard for our VM instances. Currently, there are no VM instances in this project. So let's go ahead and create one by clicking on Create. So this brings us to the page to create a VM. So here on the left, we have three options. We can create a new VM from scratch, we can create one from a template, or we can choose something from a marketplace. Choosing something from a marketplace is deploying a ready-to-go solution such as a LAMP stack or even a WordPress application or a specifically pre-configured machine. So in this case, we're just going to create a new VM machine from scratch. So on the right-hand pane, the first thing is to create a name. So just call it VM1. And we can choose the region and the zone and the machine type. So we can choose how many CPUs, how much RAM we want. So we can choose a 2 CPU, 7.5 gigabyte RAM machine, and we can choose if we want to deploy this in a container or not. The boot disk comes with a persistent boot disk comes with the OS. In this case, it's 10 gigabytes, and we can change this if we want. We can allow either all cloud APIs to access this machine or just leave things as default for now. And finally, we have the firewall. We can allow HTTP traffic and or HTTPS traffic. That's web traffic. In addition to this, there are a lot of other options under management, security, disks, networking, and sole tenancy. But for now, we'll just hit create. When the circle stops spinning, then our virtual machine would be ready. And there it is. And we can see that an internal IP address has been allocated. Now this internal IP address can be used to access and to communicate with other devices and resources that are within the same zone as this VM. The external IP address can be used to connect to the internet and to connect to other resources that are outside the region or zone, depending on the resource. So if we click on this VM, we can see the specific details. So we can see this, the location, the machine type, and the network interface card, the details for that, as well as the boot disk. Now we can edit this VA virtual machine by clicking edit and making changes to the original configuration. We can also add additional disks here. So if we press add new disk, then we can choose the name, description, and we can choose a type of disk that we want to add. So we can choose a standard disk or an SSD disk. Additionally, when you're adding an additional disk, you can also set up a snapshot schedule for redundancy and backups. So let's press save for now. So now let's go back to so we can see our additional disk here as disk 1 with the size of 100 gigabytes, which is an SSD persistent disk. Let's go back to our list of instances. There's only one, and if you want to connect to this instance, we can do so via SSH. So if we click this, a console window opens. So from here, it's the same as connecting to any virtual machine where you get a command line and you're using a Debian Linux system here.
For more details, check the link in the description. Learn with Whizlabs. Success certified.